Well, hello Pythonistas on YouTube and friends, how are you doing? And welcome to another video where we are going to try to mine Facebook pages and the information and posts on the pages and try to analyze them and also try to create a word cloud out of the information that we gather. So a little bit about Facebook pages. Facebook is not only used by individuals who want to connect with their friends and relatives, but also by companies, brands, and organizations who want to engage with people. A Facebook page is created and managed by a Facebook personal account, and it can be used in a variety of ways, like to share information about a business, for example, a restaurant or online shop, or to represent a celebrity, for example, a footballer or rock band, to connect with an audience, for example, as an extension of an online community. So different from personal accounts, pages can publish posts that are publicly visible. Regular user can like a page, meaning that they'll receive the content updates published by the page directly on their news feeds. That is their personalized Facebook homepage. And for example, I have my own Facebook page. Tiger Style Code Academy. This is my own page. Well, we'll be also trying to connect with the Facebook page of Packet Publishing. And it contains general information about PacketPub and my own page as well as the posts related to Python on my page. And with PacketPub, it's to books, ebooks, and video tutorials as well. So the API documentation for the pages, we can see a variety of information available for a given page. So to have a look at this, it's lots of information. And also below, approximately here are the edges. So a page object can also be connected to other objects, and the documentation describes all the possibility in terms of edges, that is connections with other objects. And specific types of pages can also display additional information that is tailored to their type of business. For example, a restaurant can show their opening hours, a band can show the lists of band members, and so on. So let's run the first script, which queries the Facebook Graph API to retrieve some of the basic information about a particular Facebook page. So let's run it. So you can pause the video if you want to follow along, or the files will be available for download in the link description that you can purchase from BinPress. Let me clear this out. And let's run the script. So bigger, and we will take our own academy. So when we run this code, we get the basic information like this. We get the website, name, about, ID, likes. It's the pages that is liked by this page. So the next part is how getting posts from a page. So after getting the basic information about a page, we will examine the procedure to download posts published by a page and store them in the usual JSON lines format that allows analyzing the posts later. So the procedure is similar to the one used to download the posts published by the authenticated user, but it also includes information to calculate user engagement. So this is the code. Pause the video. So we will first download for PacketPub, just to get any idea. And to run this script, you can see here we don't have any JSON-L files here. And when we run this script, page posts, and page is PacketPub first. Now we have the JSON-L files for PacketPub, and now let's just get the post for my own page. Did I change it correctly? Yes. And we should have another file here as well, which is for mine, and I'll get back to it what we are going to do with these files. Just make sure that you download the files as JSON-L files. So what this script does is that it uses an instance of argument parsers to get the page name or page ID from the command line, as well as the number of posts that we want to download. In the sample code, the number of posts is optional. It defaults to 100. As we did earlier when we downloaded the post from the authenticated user, we will define the list of fields we want to include in the results. In particular, as we'll use this data to perform some analysis related to user engagement. We want the results to contain information about the number of times a post has been liked, shared, or commented on. This is accomplished by adding the shares likes.summary true and comments.summary true fields. For likes and comments, the extra summary true attribute is necessary to include summary statistics, that is the aggregated count. So the download is performed in a while true loop using an approach similar to the one used for the posts by the authenticated user. The difference is given by a downloaded counter, which is incremented for each retrieved post. This is used to set a limit to the number of posts that we want to download, mainly because the pages often publish a huge amount of content. So when you run it, we'll query the Facebook Graph API and produce the JSON.L files, posts underscore and the page name .jsonl files. So as we can see, the post is a complex object with different nested information. The fields that measure user engagement are share, likes, and comments. The shares field only reports the total count of users who have shared the story. Other details are not included due to privacy settings. When a user shares a piece of content, they are effectively creating their own post. So this new post shouldn't be visible to other users outside their network. The comments and likes fields, on the other hand, are objects connected to the post itself, so there are more details available to them. So, and the comments object also includes a paging field, which holds the reference to the cursors in case the number of comments exceeds one page. Given the original request with an explicit reference to the summary true attribute, short summary statistics are also included. In particular, we are interested in the total count. The likes object is somewhat similar to comments object, although the data is less complex in this case. Specifically, there is a list of user IDs for users who have liked the posts. Similarly, we also have summary statistics with the total number of likes, as the summary true attribute was specified in the request, which is here. So once the data has been downloaded, we can perform different types of offline analysis. To start off the analysis of posts published by a Facebook page with some discussion related to user engagement. So the data provided by the Graph API includes the following details, like the number of times the post has been shared, and the number of users who liked the post, the number of users who reacted to the post, the number of comments on the post. Sharing, liking, and commenting are all, in fact, the actions that a user can perform with a piece of content published by someone else. Why it is difficult to understand the true reasons behind a specific action, for example, how to distinguish between a sarcastic like and a genuine one. And a deep analysis on the psychology behind such actions is beyond the scope of this tutorial. So for the sake of this data mining example, we'll assume that posts with more interactions are more successful. The term successful is in double quotes here, as we haven't defined the precise meaning of success. So in this tutorial, we are just counting the number of times the users have interacted with the page. So the following script prints some information about the post published by a Facebook page that has received the highest number of interactions. So I will use in two ways. On two pages, Facebook IDs. I will use it on my own first. So there's a post that got 14,692 likes, 34 comments. So let's do this same for PacketPub. You can do it on any page you want. So yeah, I forgot to mention that with most interaction, you get the message that is in the Facebook. So here's the top post with the from PacketPub, which is a message about NASA, sorry. And it has 187 likes, 0 comments, 136 shares, total 323. So again, a little bit of explanation about the script. The script uses argument parser to take the command line arguments, and it can be run from the command line with the arguments that we showed, with the Python and file script name --page and PacketPub, or the page name of the page of the JSON idle files that you have collected. And as we loop through these posts, we introduce all interactions key for each post, computed as the sum of likes, shares, and comments. If the post has not been shared by any user yet, the shares key will not be present in the dictionary. So the access to post shares count has been included in the try except block that defaults the number of shares to 0 if the key is not present. The new all interactions key is used as a sorting option to the sorted function, which returns a list of posts ordered by reverse number of interactions. So this is the output that we got. So while finding out the post with the highest number of interactions is an interesting exercise, it doesn't tell us much about the overall picture. Our next step is to verify whether a particular time of day is more successful than others. That is, whether publishing a post at a given time gives us more interactions. So we have another script which is here, and the following script uses pandas.dataframe to aggregate the statistics of the interactions and plots the results using 1 hour bucket. So we also did this in the, did this earlier for the authenticated user. And I'll please pause the video and scroll down as you can if you want to follow along. So let's use this on Packet pub again. So what this does, it will create a PNG file, an image, which is interactions per hour. So we get a nice bar. Oh, we can see at 11 o'clock is the busiest time for them. So the code loops through the JSON-L file, building lists to store various statistics for each post: number of likes, number of shares, number of comments, and their overall sum. Each of these lists will be a column in the data frame, which is indexed using the creation time, just the time, not the date, using the resampling technique that are already applied before. All the posts published within a 1 hour bucket are aggregated and their frequencies are summed up. For the sake of this exercise, only the overall sum of interactions is considered, but it's also possible to plot the individual statistics separately. So the plot shows the highest number of interactions in the buckets labeled from 10 a.m. to 11 a.m. Okay, that was the analytics part. Now let's get on to doing something fun. So let's try to visualize the post as a word cloud. After analyzing interactions, we move our attention back to the content of the post. Word clouds, also called tag clouds, are visual representations of textual data. The importance of each word is usually represented by its size in the image. So in this section, we will use the word cloud Python package, which provides an extremely easy way to produce word clouds. Firstly, we'll need to install the library and its dependencies in our virtual environment or anywhere you like. I like to install in my system because I use this libraries a lot. So just go ahead and pip install word cloud like this if I have already installed it, and you also need to install Pillow. So Pillow is a fork of the old Python imaging library, which was also shortened PIL project, as PIL has apparently been discontinued. Among its features, Pillow supports Python 3, so after this brief installation we're good to go. So let's go over to the script. Again, the script reads the JSON-L files that we collected earlier as the one produced to store the posts from PacketPub, and creates a PNG file with the word cloud. I'll use it on both PacketPub page posts JSON-L file and also my own. So just to explain a little bit first, as usual, the script uses an instance of argument parser to get the command line parameter, the page name, and the page ID. The script creates a list, all posts, with the textual message for each post. We use post.getMessage instead of accessing the dictionary directly, as the message key might not be present in every post. For example, in case of images without comment, even though this event is quite rare. And the list of posts is then concatenated into a single string text, which will be the main input to generate the word cloud. The word cloud object takes some optional parameters to define some aspects of the word cloud. In particular, the example uses a stop words argument to define a list of words that will be removed from the word cloud. The words that we include in this list are the standard English stop words as defined in the Natural Language Toolkit NLTK library, as well as a few custom keywords that are often used in the PacketPub account, but that do not really carry interesting meaning. So let's try this file out. Excuse me. Or name of the posts. So I should create a PNG file with, and we can see Python is the biggest word, and let's try it on PacketPub. And this would be there, and it says HTTP and ebook, learn, application are the words that they use most. So this is a nice way of just getting the word cloud, which has been really fun. So this is it for the Facebook series, and all the codes that scripts and source code for all the exercises will be available for download in a description link, so check it out. So this video tutorial series about Facebook introduced some data mining applications using Facebook, one of the big players, if not the main player in the social media arena. After discussing some aspects of the Facebook Graph API and its evolution, as well as the implication in terms of data mining, we built the Facebook app that we use to interface with the Facebook platform. So the data mining applications shown in these tutorials are related to the profile of an authenticated user and Facebook pages. We saw how to compute statistics related to the publication habits of the authenticated user, and to the interactions of users who follow the updates of a given page. Using simple aggregation and visualization techniques, this type of analysis can be carried out with a relatively small amount of code. Finally, we used a technique called word cloud to visualize the important keywords, which hopefully represent important topics from a bunch of published posts. So in the next video series, tutorial series, is about Google Plus, one of the most recent social networks developed by Google, and we're going to have some fun there. So I hope you enjoyed this video series, and if you did, please subscribe, share, like, comment on my videos, and give me some feedback if you please, and I hope to see you in the next video. Okay, bye for now.